Hi, I'm Ryan Etheridge, and this is my Build a Linear Regression Model project. I chose to do a house price prediction model, similar to the one that we did in class. So this project predicts housing prices using linear regression based on property features. I chose this topic because real estate is a major investment decision for most people. This model will assist buyers with estimating fair market value, helping sellers and pricing their homes competitively, and is useful for real estate agents and property investors. Real world application for this project would be Zillow and what they call Zestimates, or like their estimates for how much a house costs. It can help identify undervalued or overvalued properties and help with property tax assessment. So an overview of the data set, I did create a data set similar to the one that we used in class on Seattle metropolitan area housing market. The size of the data set is 25 houses. There are 5 features that we're talking about in total, and that's square foot, bedrooms, bathrooms, city, and the year built. Here is a screenshot of the data. So for the data preprocessing, for the categorical encoding, it converted city names to numeric values. So Seattle's 2, Bellevue is 0, and Tacoma is 1. I used label encoder from sklearn. The training process, so the data split was 80-20, 80% training, 20 houses, and then 20% testing on 5 houses. The algorithm used linear regression, sklearn for the algorithm. The training time is pretty quick, less than 1 second. So that's the equation for helping determine the ultimate price. So the intercept is the base price. The square foot living, each additional square foot adds $185. Newer homes add $5,678, and then location significantly impacts the price of the home. Here's a photo, screenshots of the data preprocessing when it gets output in, when the code outputs it, and the regression equation. So training R2, the model explains 98.50% of price variation in training data, and it's a great fit for training examples. And then for testing, the model explains 97.23% of price variation in test data. There's a strong generalization to unseen data, and its close to training score equals the minimal overfitting. Here's a screenshot of sample predictions that it made. So as far as accuracy goes, the predictions are within 5 to 10% of the actual prices that are listed. It's more accurate for mid-range properties. It did struggle a bit with what I would call like outliers, like super expensive homes. And then the Bellevue properties were the most expensive properties. Here's a slide of me explaining the features. So the largest coefficient was the square feet, meaning living space is the most important predictor for how much the house is going to cost. As I mentioned earlier, every additional square foot increases the price by $185, which makes sense because larger homes do tend to cost more. And then the smallest coefficient were the bathrooms. Bathrooms had the least impact on the price. And then how the model makes predictions, I wanted to just add this slide in here. So it starts at 0 when all the features are 0. It takes into account the square feet, which is the largest coefficient. It takes into account where the house is located, and then the year built, and it the slide goes into further detail about like how much pricing changes based on these features. And then what was like my reflection for the project, what was difficult? It was a little difficult to understand how to interpret negative intercepts and choosing the right features for the model, what I wanted to make important, as well as ensuring that categorical data was properly encoded and deciding on an appropriate train test split ratio. And what surprised me were the high R2 scores, above 97%, which was better than I was expecting. Square footage had a dominant influence. It makes sense. I just didn't know how much it would influence the price, as well as a few other things. I was working with a smaller data set, so that was one of my limitations. As well as only working with 3 cities. I didn't want this to take up too much time, so I didn't add like all of the United States. I just added a couple of cities from a small area. And then how to improve, I could do a couple things. I could add more features. I could add more data. I could try other algorithms. Cross-validation, feature engineering, handle outliers, and regularization, which I think would just improve this model in the end. Thank you. That's all I have.